All right, so I'm back after googling the formula for gravitation, and those of you who haven't taken physics or like me haven't or don't remember physics, where's my? That's annoying. Well, anyway, the formula for universal gravitation is the force between two objects is equal to big G, which is the universal constant of gravitation, times the quantity m1 times m2 over r squared, where m1 is the mass of object 1, m2 is the mass of object 2, and r is the radial distance between them in meters. And the mass is in kilograms, by the way. And when I mean radial distance, I mean from from one core to another core, but that's physics, and that's not what I'm teaching today. If you want to learn more physics, I suggest going to the newboston.com. He also has a YouTube channel here, and he teaches everything, including programming, and especially programming. But anyway, onto this tutorial. So the two things that we need to know, or actually we need to know three things. We need to know mass 1, mass 2, and their radial distance. So let's make mass 1 A, mass 2 B, and the radial distance R. There we go. So, so first of all, in any clean program, I like to do this, clear home. And what this does is it just clears the screen of the program header and anything that you've had before that. It just makes everything look a little bit cleaner. So I'm going to go ahead and use both ways. I'm going to use input and prompt. So I'm going to say input just for consistency. Here, alpha lock that. I'm going to say, actually I don't need to alpha lock that, M1. The equal sign is over here. M1 gets question mark, and then close quote, comma, A. So this line will display this input, which is M1 gets what, and then you input whatever M1 is, and then that value gets stored to A. And then let's go ahead and do the same thing with this. Input M2, and then second math equals, and then alpha negative, alpha negative, not just negative. Alpha negative, quote, and then comma B. So this does the same thing as the previous line, only it stores that information into B. So now we have M1 and M2. Now we just need their radial distance. And so for this one, I'm going to go ahead and use prompt. And the reason why I'm doing this is the prompt actually gives this standard input. But if I were to put prompt A, it would say A equals and B equals. And the person who's running the program would be like, what's A and B? I want to know M1 and M2. So I went ahead and put the same format, just in terms of M1 and M2, not the actual variable names. But for this, R and radial distance, those are very similar, so I'm just going to give them R. And that'll make it R equals question mark in that same format. So now we have M1 and M2 and R. And the only other data that we need is not from the user, but it's information that we already know. Now we can just put in this number in the equation, or we can just assign a variable to this beforehand, and that'll make everything a little bit cleaner later. So I'm going to go ahead and do the last one. I'm going to go ahead and well, the last data that we need is G, big G, the universal constant. And so I'm going to say, by the way, big G is 6.67 times 10 to the negative 11. Very small number. Oops. I'm going to go ahead and put this in. Okay. Go ahead and insert. I haven't gotten used to this emulator yet. So all that, store to G. There we go. So now we have G, and we have M1 and M2 and R. Now we just need to find F and output it to the screen. So now we're going to go ahead and put the formula in, which is, I'm going to put everything in quotes at the end. So, or right now, so G, that universal constant, times the quantity M1, which is A, times M2, which is B. We can put a times or we can just put B. I'm going to go ahead and put the times just to avoid confusion. Divided by R squared. So we have R and squared. And then all of that store to F. And now we can just display F. But that's too easy. So we're going to go ahead and make things a little bit more attractive to look at. So instead of just saying the number, it'll look like, what's M2, what's M1, what's M2, what's R, and then it'll just output a number, and the user might be like, what's this number that you're giving me? What does this have to do with gravitation? And so how about we say force. And then on the next line, let's go ahead and display F. And this is our program. So just as a review, this is going to be the last thing that I'm going to be doing on the video because I have a feeling that this video is running long, or it might just be that I'm really boring. Both of those are plausible. The latter probably more so, but anyway, I'm going to go ahead and go line by line and dissect this thing and tell you exactly what each line does. Then I'll run it, and then I'll send you on your way if you haven't left already. So first line, clear home, clears the screen, makes everything look a little bit fresher. Input, quote, M1 gets question mark, quote, comma, A. That displays what's in quotes here, and then waits for user input, and then when the user hits enter, whatever they input just goes into A for storage, and then this does the same thing, prints out this, waits for user input, stores it in B. Prompt R displays the pre-made prompt R gets question mark, just like this, and it waits for user input, and then it stores it into R. This stores this value, which is the universal gravitational constant, into the variable G, and then this is the equation for gravitation. This just calculates everything using A, B, and R that we just got from the user and stores it to F. This displays this string, force, colon. That sounds rather weird, but sorry. Force, and then a colon, and then on the next line on the right hand side, F, which is the new number that we've just created, or that we've just come up with using this. And just as a reminder, strings, when they're output like this, are always on the left hand side, while numbers are always on the right hand side. So let's go ahead and test this baby out, and then I will bid you adieu. So program, input. So M1 and M2 and R. Well, let's say that we have an object that is, I don't know, 1,000 kilograms, which is kind of heavy. And we have M2, which is 10,000 kilograms, which is even heavier. And then we have the radial distance. Let's say that that is 5 meters. And this is the attractive force between them in newtons. 2.668 times 10 to the negative fifth. And then done. Now just to make this a little bit prettier, I know I would send you on your merry way, but I just want to add this one last thing. I think I have told you this before, but I have a friend who does programming too, and he does this just to make his programs a little bit cleaner. He puts output 1, 1, open quote, and what that does is it gets rid of the done at the end. It's kind of a glitch on the TI-83s, but one commenter said that it doesn't really work on the later models, so sorry about that. But if you have a TI-83, then you are in luck. So let's go ahead and press enter, which that will just execute the last thing that was done. Or if we put second enter, that will tell us what we did last, which is program input. So let's press enter and execute the program again. So M1, let's say 4 kilograms, and M2, let's say this many. And radial distance, let's say 2.45 pi e. There we go. It's a nice round number, isn't it? And then we hit enter. Ta-da! There is the attractive force between them, which is actually very large, considering what we're dealing with here, which is just two objects that are, this many this many meters apart, and just the fact that they have mass means that they pull on each other with this amount of force, which will make this thing start accelerating quite a bit, and this one not much at all. But that's, again, physics, and that's not what we're teaching here. So thank you so much for watching this video. This is EpicViolinGuy signing off. And next week, I hope to, or maybe not next week, but soon, I will be back here with another programming tutorial. But for now, I will bid you adieu. Later.